Hey folks, so in this video I want to talk about how to represent our stack data in this very simple implementation we're going to be doing. So we already said we're going to be using an array. That's great. The arrays are simple to use. You've used them before in other classes, right? Why not? All right, so we have an array. So given that I have an array, right, I kind of need to figure out how do I actually put data into it. What is it going to look like inside? Well, one observation is going to be that inside of an array, all the activity is going to occur at one end, right? So I don't have to worry about changing the middle or changing at both ends. Only one end matters, right? Only one place changes. That's kind of the special place. So let's give it a name. Let's call it n, right? So we'll have a variable called n, which indicates the element at the top of a stack, right? So this is going to be our top variable, right? So we'll call it n, or we may also call it top. Usually use n here because it's shorter. But we need some indicator of where the top of this thing is, right? So here we go, we have it indicated there. And we're going to be drawing these as arrows, right, to show where the top is. Now, naturally, as I call push and call pop, things will need to be moved around, right? So this top variable, right, may move either lower or higher. So if I, for example, do a pop, presumably it moves in this direction. If I do a push, presumably it moves in this direction, right? So I need to move it back and forth. The idea being, right, is to have my array that maybe starts at index 0 over here and ends at index k over here. And this lowermost index is basically going to record the very first thing it was at, right? So the first thing I pushed is going to be at the very bottom, right? Then the next thing, then the next thing, then the next thing, right? So remember one video I did like A, B, C were the ones that are pushed on there. In that case, right, A was the bottommost, then we had B, then we had C, and so on, right? So we have these different things built on one another, right? Where 0 is the very bottom and we're adding things on top of it. And as we push and pop, we're going to have to move our arrow back and forth to represent that we're having, that we have different number of things in there. Okay. If I do many pops, this is going to drift to the left. Eventually, n will be like 0. If I do many pushes, it'll drift to the right. And eventually, it'll be the size of the whole thing, right, or k here. All right. So this is our basic idea, right? This is how we want to implement it, right? Is using this n variable to keep track of where the top is in this array. As a kind of an exercise for yourself, maybe ask what would happen if you tried to basically have it flip the other direction, right? So maybe you had the oldest thing over here, right? This is maybe this is like the 0th element added, right? Then the first element added, 0th element added, and then the first element and so on, right? Imagine what would happen if you flipped that direction, right? Instead of keeping the oldest thing at 0, what if you kept the oldest thing at k, right, at the end of the array? Ask yourself what would happen if you did that. And what would happen to the performance. So just make a note, try thinking about it later on. We'll come back to another point. All right, so continuing, let's say initially we have n equal to 0, right? So this is actually interesting because it can mean kind of two things, right? So n can be a variable that represents basically the size of the array, right? So there's n elements in the array, right? And they initially are 0, right? That makes sense. Also, n can have the following meaning. It can be the next space to add an element to. Okay, so I'll actually have those dual meanings, right? So n is the number of elements, is also the next place to add one. So initially n is going to be 0 because there's nothing in there. So what happens if we do a push? If we do a push, we're going to basically add an element. So here we've added a 7. We add that element to the array, right? So the array is implemented, and then we increase n, right? So n goes up by 1. I have one more element in there. Okay, so n is now equal to 1. I do another push, right? I push, for example, 2. I have to change my array, add that 2 in there, and then increment n, right? Now n is 2. So notice here, right, that I basically added two things, right, and that meant that I had to change the array twice and I had to do 2 increments, right? And you can look at n is the number 2. Well, that's the number of elements in the array. It's also, in addition to doing just the number of elements in the array, it's also the place where the next thing would go, right? And this is kind of a side effect of the fact that we have our array starting at index 0, right? We get that kind of dual usage. And that's going to be useful for us later on when we do the actual implementation. All right. So what about pop? If we did pop, as you can probably guess, our arrow would have to move backwards, right? So instead of it being over here, it would move back to point at number 2, and number 2, right, would probably go away, and we have to decrement this, right? So a pop basically is a negative, right? I do minus on my n variable instead of plus plus to pull it back. And I guess strictly speaking, I don't even really need to erase the number 2 because my n variable, right, is what tells me, is this a useful space or not, right? And if n is pointing at this one slot that has, for example, that number 2 in it, I didn't bother to erase it even though I did a pop. Well, that's fine because I know that n is basically the next position for me to add something new to. So when I add something new, it'll override that number 2, right? So all that's going to be fine. So we won't have to worry about that. All right. So this is our basic setup, right? So this is how we're going to use the array. This is how we're going to use it to implement pop. We're going to use it to implement push. In the next video, we'll take a look at the actual implementation of all of this.